All right, looks like we're rolling along here. So anyway, I've been interested in the Dodge coal storage system that was in Middletown since the 60s when I heard about it. But I had no idea what it was. And there were no photos that I was aware of. There was this one postcard that I finally found, and it has these weird things basically drawn in the background that's not photos. And that sure doesn't explain much. But over the years and using the archive's resources, we've improved on that a whole lot. This isn't exactly the same photo that was used for the postcard, but pretty much the same perspective taken from the top of the locomotive coaling station. Anyway, it shows the storage area in the background. We'll get into those details in a minute. So why even store anthracite? Well, in the spring and summer, without fixed storage, the coal is in low demand. It's, most of the anthracite was used for heating, although some was used for industrial processes. So the price would drop. And instead of trying to sell it on the market at the lower price, if some of it is retained, then it can be sold later. And also, before much fixed storage was built, the O&W would store coal in hopper cars, which tied up the hopper cars, made a scarcity of cars, and even restricted mine output if there were no cars to haul. And with storage, it freed up the transporting. You can sell the coal at a much higher price in the fall and winter. And then in the winter, you can supplement the rate of mine coal coming out by reloading from the storage areas. So that's a big reason. And this is all from the annual reports. So this photo is pretty interesting. There's 3 types of coal storage shown. This is Middletown. On the right side are lines of hopper cars just sitting there, holding coal. On the center foreground is a coal trestle that they built, and there's coal underneath. They would dump it there, and we'll talk about that. And then on the left is the early version of the Dodge coal system. So again, 3 types of coal storage. So when they built the Scranton division, basically in 1890, primarily for coal, they realized they would need storage, and they figured at Middletown and Hancock, meaning Hancock Junction, but they called it Hancock. And so that was 1889. By 1891, they settled on the Dodge system, which was a good choice. In 1900, they built a coal storage trestle in the yard. We'll talk about it, holding 20,000 tons. Then 1901, 4 Dodge piles, which would store 120,000 or 130 or 40 if real need be. Then 1908, they added 2 more piles for another 60,000 tons. 1935, I guess they had non-vibrating screens because all the reload towers had screens to screen out fines, but they added vibration from electric motors, and that helps the screening work better. And then finally, the whole Dodge plant and coal yard were retired in 1946. Anyway, when they built the Scranton division, coal shipments rose nicely. Actually peaked 1895, and they were kind of leveling off. But then in the last 2 years after that, they were jumping up quickly. So they really had to move on this. So in 1900, they built that coal trestle right in the yard, and it was primarily for pea coal. And it was 35 feet high, although some reports said 32, and 810 feet long. Some reports said 650, depending upon what portion you mean. And it was steep. It was on a 4% grade. And they would dump coal on the ground, which would be picked up by a steam shovel. And again, 20,000 tons storage capacity. This is what it looked like. And you can see the steep grade. Now, this is looking a little bit from the end, so it looks steeper than it was, but 4% is a steep grade. And this is a piece of a bigger photo. And even though this doesn't directly involve the coal storage, I have to show you the whole big photo, because here's the early setup of the shops and even the roundhouse, which was near the main line in this case. And this is all before they got relocated, like in 1910 or so. So it's just an interesting photo, but you can see the coal storage trestle right here. Anyway, and here's Middletown Yard in my thing blocks the title, but in 1900. And the only storage they had was the coal trestle right here, the 20,000 tons. And again, here's the roundhouse and the shops area. This is the transfer table, which they eliminated later. Well, by 1905, they had built 4 piles of this Dodge coal system and additional tracks. This is part of the coal yard for staging coal trains and hopper cars. And they still retain the coal storage trestle. And at this point, they still had the roundhouse and shops in the old configuration. And here's 1905. That was 1901. I'm sorry. This is 1905. They added additional yard tracks, largely for coal train handling. And then finally, by 1916, they had major changes. They added 2 more coal piles. They got rid of the coal trestle. They moved the roundhouse, moved the shops, and filled in the yard, making it that much more efficient. And they added this engine coal storage thing over here, which we'll talk about. So now with the 6 piles, it was 180,000 tons capacity, although every pile could be kind of pushed, so it was probably over 200,000 tons capacity in reality. So what was the Dodge system? It was a very good system, we'll see. It was made by James Mapes Dodge, and part of Link Belt, and he created the whole Dodge Coal Storage Company. He had over 100 patents. The Dodge chain was one of them, and the Dodge system was a patent in general. Now, this is not the car maker, not Phelps Dodge, and not Dodge Manufacturing. If you Google and stuff, you tend to find some of those other things. You have to discriminate. Anyway, so the Dodge system consisted of units. This is called a unit with 2 piles, and they could, and you'd have 3 tracks involved. A dumping track, you dump coal in a pit, and then it would be loaded onto this big giant pile, or a pile made from that. You could also unload it here and make the pile here. And then you had this reload boom that could swing back and forth and remove the coal from these piles, run it up a ramp to a reloading tower. Now, in that process, even though this whole system was very good at not breaking coal, some would get broken anyway. So you get some fine pieces, and people didn't want that. They wanted nice lumps of coal at whatever size they're buying. So there'd be a screen on the reload tower that would let the small pieces come through, and that would be dumped into cars on this screenings track. And then finally, reloading cars on the reload track for shipment. Again, that would be done in the winter type thing. And this reloader boom rode on circular rails. You can see a whole bunch there, and we'll talk about them later, but they're all circular rails with the centers at this pivot of the boom. And the tracks here were built on a 1% downgrade So you wouldn't need locomotives to keep moving car to car. You'd set them up and then they could just release the brakes and roll them down the 1%, and then to add different cars to unload or load. So, okay, so the big thing everybody notices and a big impact to the town is these big giant piles, and so they're pretty visible. And anyway, we'll talk about it, but all kinds of activity around them. This shows the shops in the background. This was the new configuration of the shops and one of the trimmers. We'll talk about these individual details. This is one of the reloading booms, which we'll talk about too. And this is one of the reloading towers and the engine house that runs it. This is the boiler house to generate the power. Again, we'll talk about that. Lots of track work with slip switches just for flexibility. And still lots of stored coal just for staging. In some cases, stored just to be moved on later, but in a lot of cases, it's staging to be taken to the system to either build a pile or to load cars to ship out. And this was a big part of the Middletown yard. This whole area they called it the coal yard. And they even have, when they had two shifts of switchers, there'd be one at the north end, highlights, and then the other, they called it the coal yard engine or the coal yard job. And they would be switching this end by Wisner Avenue. So the Dodge system had some really major advantages. It was elegantly simple. It was just clean and very direct. And it was the least expensive to operate, 4 cents per ton to make a pile or to retrieve it. And the screening capability, and it had the least breakage of coal. Other systems, the different conveyor methods and getting them from one conveyor to another would break coal a lot. This had a very low rate, 1.5%. So the key to all that is they don't just make a pile by running the coal right up to the peak and dump it, because it would fall like 35 feet or more and break a lot. So they would have a way to build a small pile near the base. Once that's full, they could build more. We'll talk about that in a minute. Another key is on the reloading. It was a single conveyor instead of one conveyor passing it to another. The conveyor would grab coal from the pile and run it right up the ramp into the reload tower, so it could be put in a chute into the cars for shipment. And even on the chute, they don't want to just flying down the chute into the car, because again, that would break coal. So they had a gate at the end of the chute that they could keep closed until the chute was full of coal. Then they could lower the coal or the boom into the car and then open the gate. So the coal would just kind of flow into the car instead of dropping in and again breaking. So those are the three keys that made this system so popular. So how did it all work? Well, first thing you need is power. So they had a boiler house, and one boiler house ran the whole system, whether it was 4 piles or 6 piles. And as you can see, 2 boilers, 20 feet long, 6 feet diameter, 150 horsepower each. And they would burn screenings, those fines that they would get in the process. They were pretty invaluable, so burning them was very efficient. A steam blower, and then they would run insulated pipes to the engine houses where steam engines were to operate things, and insulated, of course, and supported on A-frames. And they probably have these special things where when the pipes get hot, they expand, so they had expansion angles and things. and they had a big well that they drilled to supply water. And so then each unit, meaning pairs of piles, had an engine house with a single 100 horsepower engine. And then, just a minute, let me, whoever that is, if you could mute yourself, that would be good. Anyway, they had jack shafts and belting to run various shafts, and eventually rope sheaves, which is kind of like the pulley on your fan belt. We'll talk about that. Gears, jack shaft, clutches. Now these clutches aren't like an automobile clutch. They're square jaw clutches. They're either fully engaged or fully unengaged. There's no half about it. And chain sprockets, because there was some chain drive flying around. Cable drums, which we'll talk about. Drum brakes. And manual and remote control. Now, the remote control was done by cables. I don't think it was an app on like a horse-drawn iPhone or something. So anyway, so, okay, now they're generating power. They have to transmit it to where they need it. So for the trimmers, which was the big A-frame things to generate the piles of coal, they needed to pull the conveyors from the top of the trimmer. So they needed to get the power all the way up to the top of those A-frame things. And they did it with rope drive. So here's an engine house, and here's some of the rope drive coming around pulleys. Now this is a special thing, a slack reducer or slack eliminator thing with a heavy weight, because anyway, this rope was 1.5 inch manila rope, and it could get wet or dry and shrink and stretch and all that. So they had to have a way to pick up that slack, and it could handle 7% shrinkage of the length. Anyway, it's a little blurry, but you can see the ropes coming. They go around these big pulleys just to change direction to get to the bottom of the trimmer trusses. And here's side view of a trimmer. These are just idler pulleys because it's going all the way to the top of the trimmer up here. So this 1.5 inch rope runs this big sheave, which then runs a shaft and a bunch of gears, gearing way down, because inside here is the thing that actually makes the conveyor operate. This is just to get power to it, but this is running the conveyor. We'll talk about that. Anyway, so the setup of the wheels or the rope drive inside the engine house, they have a driving sheave and again, different pulleys to change directions. Here's your tension carriage. So a big heavy weight, just maintaining tension here. So when the rope stretches, you don't have any problems. Again, lots of idler wheels here and changing direction and going all the way up to the top of the truss, which is a big sheave to run the rope thing to run everything. So anyway, and the whole rope is like this giant sort of a serpentine fan belt, but made out of 1.5 inch manila rope. So, and it moved at 50 miles an hour to transmit all that power, and they would run 50 horsepower basically on the rope, and so there would be 380 pounds tension. Now I'm sure that would jump up and down as things change, but that's averages. And the tension carriage again could handle 7%. And this rope, they would have to replace it or patch it, and they could make long splices in the twisted rope. Apparently they were easy to make and they passed through the system very well. So that was a practical good thing. Anyway, so storing the coal. Again, it's really critical that you start with a small pile and never drop the coal very far. So in this case, they probably started way down here. And even though you're starting here, you're not going to end up with a giant pile here because you keep moving the dropping point. So now we moved it to here. And so at that point, you move the dropping point a little further up the truss, and now you're making a new pile. And okay, it's gotten there. Then you move it again a little further, let that continue until it's bigger. So eventually you keep doing that until you get to all the way to the top. But in all cases, the coal never dropped more than 3, 4, 5 feet, not all the way down from here. So that keeps the coal in really good condition and all uniform size. And here's an empty thing. And so they would start with a little thing and eventually just grow it to the full size. Anyway, these trusses were really massive, 75 feet high. So you definitely don't want to drop the coal that far. And the total distance between the bases is 287 feet, 161 feet per truss. Very large things. Now, these are very light duty relatively. So what about wind or something? It could be blown over. Well, they had guy wires running, in this case, to and from the way you're looking to keep the top of it in place. And so the one end, I call it the dumb end, nothing going on here. There are no pulleys or ropes or anything here. It's just holding that end. And these two trusses are actually hinged at the top. It's not trying to maintain stiffness up there. The way they maintain the position is there's a cable underground from this base to the base of the other end, the other truss. So now you have a triangle, and which is very strong. So the truss was, the truss, which they called trimmers, supported and drove the conveyor for piling the coal. And the conveyor it's known as a scraper conveyor, at least nowadays. And it's not like a conveyor belt. It's a trough, and you have these blades that they called flights that would just scrape along the bottom and just push the coal along, drag it along the bottom of the trough. So the chain, the Dodge chain, again, that's an invention of the Dodge guy, 7/8 diameter links, the steel in them, 7/8 diameter. And the flights were 9 inches by 27 inches, except not rectangular, you'll see, and 1/4 of an inch thick, every 18 inches. And the bottom of the trough was 12 inches wide, and it had a ribbon of spring steel, 1/8 inch thick spring steel on the trough. And that could be pulled up to the top of the trough or brought all the way back to the bottom of the trough. So as the coal was being dragged along it, it would just get to the end of this ribbon and fall out. So that's how they allowed the coal to come out initially low on the whole truss, and then as they pull the ribbon up toward the top, then now the coal is coming out a little higher, and they keep adjusting things as they go. And the chain moved 200 feet per minute, which is only 2.2 miles an hour. And at 50 horsepower, there were 4 tons of chain tension, which isn't that much, but again, I'm sure it would peak at maybe double that. And they could supposedly load or store 180 tons per hour, but I've seen something as high as 350 tons per hour. So the Dodge chain, the real key to it isn't just the links. It's these little malleable iron blocks between the links. And they were set up with grooves. So like this link here, it shows can be rotated, but it's not floppy like most chains. And this link can rotate in and out of the picture here. And the malleable iron would get anywhere. I don't know if they had to ever replace these, but it would be easy. You just slack the links and you can pop that out and put a new one in. I don't know if it ever got used enough to need replacement, but possibly. So here's an example of the chain. It's kind of a junky picture of it. There's a Dodge chain. These are the plain links, but then they'd have, and here's another picture of that funny little link, or the malleable iron thing. So some were plain, some had mounts for the blades, again called flights. So here's the chain with the links. There's that little thing. Here's a little thing, but with mounts for the blades. And here's the type of blade that would be used on the trimmer to bring the coal up to the pile, that shape. In fact, this isn't Middletown. This is probably Hawto out in Pennsylvania, but it's kind of a neat view. But it shows these are those flights. Now, these aren't the ones that brought the coal up, but now they're on their way back down the trimmer. It's a continuous loop. And anyway, it's kind of a neat thing. Here's the reloading tower, which we'll talk about later, one of the engine houses. Here's another pile at Lake Hawto. They had piles on both sides of the working track. But anyway, so it starts with they have a dumping pit. And again, 3 tracks, the dumping track, the screening track, and the reloading track. So they dump into a pit, but they didn't want to overfill the pit. So this control here would control the gate. Actually, it wasn't so much not filling the pit. They didn't want to overload the conveyor. So these scrapers, it doesn't show directly, but the scraper chain with those blades is coming around here. Oops, sorry. Coming around, and the bottom of the blades runs along the bottom of this trough and then ends up going up the trough of the trimmer. And we'll see that more. Now, this is, I forgot where this is. It's not Middletown, but obviously the pits would have grates so people wouldn't fall in and big lumps of coal wouldn't foul up down in there. Now, this is a different operation with 2 pits for dumping, but O&W didn't use that. So here's the base of the trimmer. And you can't even see the blades because they're down in the trough, but you can see the ones going back. These are the empty ones, and they've gone around the wheel, so they're upside down. And right there is the control for the gate that allows the coal from under the car to get onto the conveyor. So again, you don't choke it. So you set up a rate to where it's practical. Anyway, so here's effectively a drawing of the trough itself. So you can see the shape of the blades. Here's that 12-inch wide spring steel. Here's the rest of the trough, just the 2 sides. But you'd have a cable on the upper end of that ribbon. It would go around a pulley at the top of the truss, and you could then pull on this cable to bring the ribbon up the truss toward the top. When you wanted to reset, there was a machine where you could pull the whole ribbon back down onto a drum. In fact, this is it. So here's the drum to hold that ribbon, and there was some way to power it. This would be really hard to pull up or down. Anyway, this would be the ribbon drum. There's a ribbon. Then you'd have another drum with a cable that would pull the ribbon up, or again, you rewind this drum to pull the ribbon down. So I kind of estimated how many employees you would need for storing coal. So you need a couple in the boiler house. I think only 1 in the engine house. Just didn't really have to do much. Just see to things, keep things lubricated. A switching crew, and then you would set up cars again on the 1%, and you'd have somebody running the handbrake. Once in a while, you need one of those manual car movers to get it going. So probably 2 guys involved there. Then it's really hard to open hopper car gates. You probably have 2 guys there, and the guy to control the feed to the conveyor, and somebody to watch the coal pile and adjust the dumping point, pulling the ribbon up as the pile grows. So how do you retrieve the coal? Excuse me. Again, a single conveyor moved the coal from the bottom edge of the pile up the incline. So there's the thing. So this reloader boom, here's the thing going up to the reload tower. Here's the end of it. It's kind of like a big chainsaw. Here are the blades, and they go around. In fact, this is the loop of the conveyor. So goes around, picks up, well, it goes here. On the way back to the reload tower, say there's coal here, they push it against it, and it gathers coal and just scrapes it along, makes the transition, goes up the ramp, and dumps it at the top of the tower. And you can see the flights, they call it, and the chain goes around these special wheels that can handle that chain. Anyway, so these blades are rectangular and they ride on a flat base, but there's no side to the trough. There's one on the inside, the left as we hear. But right here, this is where they push this against the coal pile. And then they're pulling all these toward the reload tower again. This just shows the flights and the chain a little bit better. There's those little links or malleable fittings between the links. And here's one that has the mount for the flight. So if you're unloading the right pile here, then you'd want to run the conveyor. The conveyor can go either direction, but obviously if you're taking coal from this pile, you pull in this direction because you're always pulling toward the ramp and then up the ramp. And so you then have to move the whole conveyor toward the pile. And as the pile gets reduced, you have to move it closer. So this is what it would look like pulling coal. I'm sure it's a sloppy process, but it keeps coming. So you keep working that. And okay, you removed all the coal, but no, you haven't. You left a whole bunch out here and a little bit here. And it's just the way it is. It's like windshield wipers on your car don't clean the entire windshield. They miss some. So what do they do about that? So we'll get back on that. So anyway, the conveyor for the reloader is also 7/8 inch Dodge chain, but the flights are bigger, 8 by 18 and thicker because they're pulling harder. And it's reversible. 50 horsepower, again, 4 tons chain tension. And the 2.2 miles an hour, just like the trimmer thing. And again, 180 tons per hour, up to 350. I see different news articles that talk about things, and the numbers vary. So anyway, the reloader boom, that big long thing, again, it's kind of like a chainsaw blade, except it can go either way. And it supports the conveyor itself, the chain and flights. And it's pivoted at the base of the incline and can go 103.5 degrees to either side, 261 feet long, almost the length of a football field, and 10 feet wide. It's a really long thing. And remember earlier on that picture of the unit, the top-down drawing, the rails that it rides on are circular with the center at the pivot. And because everything's controlled, they don't need flanges like regular trains do, because everything's controlled in position. So to move the thing, the traversing drive uses wire rope. Now I sometimes call it wire cable, or steel cable, but it's officially called wire rope. And it's wrapped along a motor rail. Well, what's a motor rail? Well, it's one of the rails, the circular rails. And before we get to that reloader thing is really long. Look how long it is. Basically, it goes almost the full length of the big trimmers, and they're like 2 275 feet or 285 feet. It's like 261 feet long, this reloader thing. It's this long, skinny thing. Anyway, so for traversing, it required a really strong drive method. So they used 1-inch wire rope to directly pull the reloader to either side. And the wire rope was wound on drums in the engine house, and they're controlled remotely. And the wire rope could move at 1.3 feet per second, which is roughly at 1 mile an hour. So this was, again, to move the whole boom into the pile of coal or to move it away from it, and you didn't need to move it quickly. So how does that whole concept work, where you have a cable that goes around a rail and stuff? So it's kind of like if you're on a boat and you're away from the dock, but you're holding a rope which is hooked to the dock. If you pull on the rope, that causes you and the boat to be drawn toward the dock. So anyway, here's a diagram of the whole situation. And here's the reloader that you want to, or you can move either direction. So if you pull on this red rope toward the pivot, that'll cause the reloader to move to the right. If you pull on the green rope, it will cause it to move to the left. I probably should use blue to be more political or something, but anyway, and if you do, say, pull it to the right, that's going to, and to do that, you pull a red cable into the engine house. Well, that's going to then draw the green cable out of the engine house. You have to have that drum loose to where it can release the cable. And the rope that activates all this is anchored at the end of the rail, of course. You don't want that slipping. So the rope very elegantly wraps underneath the head of the power rail. I forgot what they call that. And so it's really cool. In fact, you can see it. Right, where's my cursor here? There it is. You can see the traversing rope, the traversing wire rope right here under the thing. Now, before we go on, you look at a picture like this and you can see the sides of the rails, except when they use the system and they dump a lot of coal and then they remove it, this plate probably scrapes along the tops of the rails or maybe even an inch above them. So it wouldn't remove all the coal down that far. So initially they put culm down below the railheads, but it looks like they maybe hand shoveled the good coal down to the culm. For some reason, I would just leave it personally at whatever height the reloader could take away from, leave it for the next time, but looks like they hand dug it out or something. Anyway, the setup to get the traversing rope around the rail, this is looking down at that part of the reload boom. So the rope comes along, the traversing rope comes from the engine house through the pivot, as we'll see. It's tricky. Goes around a pulley. This vertical one goes down to another pulley, which basically inserts it outside that motor rail. And here's this. Oops. And here's a side view of that. So the traversing cable goes down, and then this pulley can insert it. So there's a motor rail, and here's a traversing cable wrapped around. And then this is just one of the many wheels riding on a support rail, because this big, long 261-foot thing has to be supported every 20 feet or something. So here's even that traversing cable on the other side of the reloading boom here. So now the pivot is really tricky, because here you're pulling on a chain, 4 tons, this and that. Well, if you pivot your whole operation, you're really risking changing the path length of that whole thing. So either you make it too tight, you break the chain, or you get sloppy and the chain will jump off the rollers and everything. So it's really tricky. And then these traversing ropes have to pass through it also and not get messed up. So here's looking at the pivot area, and this is with things nice and straight. That's nice and easy. And again, here's the conveyor. Well, sometimes it's way off to the side. This happens to be Newburgh, but it's just shows the difference. So they came up with a really cool method. This is the pivot and all kinds of pulleys here. Now, these big pulleys, there's some name for them, I forgot, or for the conveyor chain. So they're sprockets and they have these funny shapes. These pulleys in the middle are for the traversing ropes, and the traversing ropes switch sides here. And this one switches over to there, and this one switches over to there. So that way, it just handles as you change the angle of this boom, the traversing ropes stay in good condition. But still, how do you handle the angle with the conveyor chain? So here's a diagram, basically like the other one, but it shows a little more clearly. Get my cursor here. So the traversing ropes switch sides, as you can see, and the conveyor chain is in blue here. And this is just an idler for the base of the ramp. You'll see in a minute. But the key is this idler wheel and this one. So when the boom is pivoted all the way, oh, I'm sorry, I gotta go back. This little guy is actually the key. So when you start rotating the boom, he gets moved out and pushes against the side of the conveyor chain. And that takes up slack because right here, this path's going to be shorter if the reloader's rotated counterclockwise as we look at it. So here's fully rotated. So this part of the path is shorter, but now that one pulley has made a longer path. So the whole idea is to keep the total path length of the conveyor chain the same. And this does, apparently I haven't calculated it, but I'm sure it works fine. And you can see the funny path of the traversing cables. This happens to be a real long run, and this is a real short run, but it all comes out in the wash. So it's a pretty brilliant solution. And what's funny, by the way, at the archives, we found drawings of the Dodge coal system. It's like, great, except there's only a few drawings. None of the drawings of the whole trimmer trusses or the reloading boom or anything. All that detail was just, we don't have it. But we do have this drawing, the one I showed you right there. That's one of the ones we have, and that's really key to things. We also have a drawing inside the engine house to show the different pulleys and connections and all that, and the clutches. So we have the key parts, and the rest you can get off Google and stuff. So that's where I got it. Anyway, so here's got guys climbing on the pile. Now, why would that be? Well, probably these piles are out in the rain. You get rain, and then it gets cold, and now your pile's pretty frozen. And right as you need it, you need the coal to retrieve for winter use, and the pile's frozen. So, or at least the top of it. So I think they'd send these guys up to just break the clumps of frozen coal, so it'll drop down and they can retrieve it. So you can see the guy with the pick. So okay, so controlling the reloader, you need to be kind of quick. If you're moving it into one of these big piles, and the pile kind of sits there and then suddenly starts to collapse, it'll bury the reloader, and you probably can't yank it out. You probably have to hand dig it out or something. So if you see the coal starting to collapse onto the reloader boom, you need to quickly pull it away so it doesn't get buried. And it's all controlled from the pivot, a little platform right above it. So you have two controls. One is conveyor direction, either pull on the right side or pull on the left side or not running. And the traversing, either swing the conveyor to the right or the left or stopped. So here's what the controls look like, kind of like big bus steering wheels. So one, probably the top one is the traversing one, which is easier to control quickly in case, again, you're having an avalanche and you need to pull this boom away from the pile. And the bottom one would just be turning on the conveyor in whichever direction. So you can see he's working the pile to the right and the conveyor's pulling the coal toward the tower underneath him, and then it goes up the tower, which we'll see. And it's a little bit messy, but it's okay. Now, in some cases, the control is open air. There's some pictures of just a roof, but O&W had these triangle-shaped shelters in Middletown, and then Kedosh had a different shape. But anyway, we'll talk about that. So one of the keys is, instead of one conveyor gathering the coal and then another one taking it up, say, a tower, it was all one conveyor. So, and this would be for, this is looking up the ramp to the tower, and the boom, reloading boom, is behind you. And in this case, they're retrieving coal on the pile to our left in this view. So this conveyor's going up that way, scraping the coal up to the top of the thing. And now the empty part of the conveyor is coming back down. And these wheels are just to control the elevation of the conveyor, so when it's tight, it doesn't jump up. And then these little ropes here are control ropes, control cables, but fairly small. They're 1/2 inch or 3/8. And there's those big bus steering wheel looking things are what pull on these little controls, and those go into the engine house and cause clutches to engage and disengage. That's what these are. And I think right here, the traversing ropes, they also pass under the pivot and all that. And remember, we saw them. So anyway, then the tower has to run that conveyor. The reloading conveyor is done from the top of the tower, because everything, you need to be pulling on the load side of the conveyor system. So instead of using a rope drive, because the tower is right next to the engine house, they use a chain drive. And then up in the tower, they had a bevel gear to gear it down and change direction, so they could run the conveyor itself with a sprocket. And it had a shaking screen. At least, I don't know, again, remember, I think in 1908 or something, they added electrically shaken screens. Now, before that, maybe it wasn't shaking. I don't know. Anyway, enclosed delivery chute, the hopper for screenings, and a worm drive winch to raise and lower the chute. And that, again, manual control of the gates at the end of the chutes, or the chute. So here's the tower. Now, they enclosed it later, but the operator's here, and there's the equipment. And this shows it better. So this is the equipment. This is where you can raise and lower the chute and open that gate. This is that big wheel we saw. Let me go back. These wheels here, or these here, which keep the scraper conveyor down from taking the shortcut. Anyway, so it goes up the ramp. Here's that big bevel gear right here from the, well, here's the powerhouse with the steam engine. Here's the chain drive, goes to this, and then another chain drive goes over to this thing. And that, with a bevel gear, turns this big shaft, which is the sprocket that runs the whole conveyor. So that's how the conveyor gets moved. Here's a little hopper for screenings. It's not real big, so but they can block the bottom, so when they change cars, it doesn't just drop on the track. And here's a small hopper, I guess there is no hopper for the actual reloading coal. They can stop the conveyor while they're moving from to a new car. They just stop everything. Again, keeping the coal in the chute. They want to keep it flowing versus dropping down, so they can close this little gate. Anyway, here's a clearer view. Now this one, now they've enclosed the operator's area because a lot of this work is done in the winter. Obviously, it's a little cold. So here's the hopper for the screenings. Here's that chute that they can lower into the car. And again, the engine house. From the other side, basically looks the same, only different. And you can see the conveyor, the two sides of it. One would go up, one would go down, depending upon which pile they're retrieving. And of course, they had ways to get up to the tower. And the engine house had a steam engine in it. I guess this is for the exhaust for the steam engine. It's only 100 horsepower, so not much. So there were 3 units eventually. Each unit had one reloading tower. So one's just out of sight to the left. Here are the 2 others. And here's a close-up. So in this case, they're actually filling this car. You can see this portion of it is full, and they have a guy on the handbrake, and he's letting the car roll. So as the coal continues out, it'll fill toward the end of the car. And I think it's a great photo showing that. This may be a scale house because they probably weigh each car. Once it's full, they weigh it quickly and then move it on and record the weight. But they need to know how much they're shipping out. Yeah, there's the guy closer up. There's the guy on the brake wheel. And you can see that this end of the car is full. This is still empty. So, but they'll let it roll downhill, which is to the left, and to fill the car. So for reloading, you need about 13 employees. Again, 2 in the boiler house, 1 in the engine house, switch crew, car moving, a guy on the handbrake, 1 on the car mover, reloader boom controller, reloader chute controller, and a car scale operator. So, okay, so again, this one photo shows that they leave a lot of coal behind when they retrieve the coal from the pile. Where's my cursor? There it is. And so what are they going to do? Well, they leave coal in 2 places. One is past the end of the reloader, they miss a lot. And then right in here, they can't quite get to the very end of the pile. So there's an example of the end of the pile. It's still a lot of coal, but that's the small one. Behind this photo where the reloader couldn't reach is a big one. So they don't want to leave that there. So the key, O&W had the option, or used the option, on the end of the big long reloader. Here's this thing sticking up. What the hell is that? Well, we happen to have plans for that too, which is, it's powered by a sprocket, which is, here's the base, the plate that the conveyor rotates on, and there's a big sprocket here that it goes around. Well, when the conveyor is running, that sprocket moves, rotates. So they have gears from that can drive. They have drums, cable drums, and they have a couple, and it's all controlled by these big levers here. The guys can stand here on the platform, and there's a couple of levers to engage and disengage the drums. So what does that do? Well, Here's a case. This is one of those things. You can see them with the levers. One of the drums comes out here, and they run it around a snatch block, a pulley, basically. Another one comes out, and they run it through a snatch block back here, and then to this thing. This is a little drag plow. And they also have posts around the perimeter of the big piles, and they could, just manually hook this all up to this post. And if he pulls on this cable, if he causes the drum that's attached to this cable to pull, it'll pull this scraper blade toward the center. And if there's coal out here, it can bring coal that way. And then he can let this one loose and pull on this one, the drum that pulls this, and that'll bring the blade back to the post, and it can go back and forth. Here's a picture of the blade. That's what they used. And so here's an example, or it's a diagram. It shows the posts. They had a bunch of them. And if you had this coal out here, you go on this post, and you could work it back and forth until you've moved all this coal into this area where the boom can get it. And then you manually hook up to this post and work that. And so I'm sure it took some time, but at least you're not hand moving all this hundreds of tons of coal. So is that the end of the story? Well, not really, because there was engine coal stored. Now that was all anthracite, and anthracite you can make the piles as big as you want, and you don't get spontaneous combustion. But engine coal, bituminous, soft coal, if you go higher than 25 feet on a pile, you risk spontaneous combustion, and you have a fire, B, you're burning up your coal. It'd be real hard to put out. You don't want to do that. So they had a whole different method for engine coal. So again, before I had access to a lot of our information, I had a val map of Middletown Yard, and it showed this weird thing in it. And even in the archives, there was some nondescript photo and this and that. But finally, we found these drawings and the archives maps and Dodge coal books, research and photos and things. So why do you even need to store locomotive coal? Well, you don't want to run out. In fact, the O&W way back in Midland times learned that lesson. They ran out of coal, and they had to burn wood, and the trains were late. Some of them were stalled; they couldn't continue. It was slow and expensive, and they even tried in 1874 to economize by burning wood, and they ended that in 1874. And one example, Middletown to Walton and back, one engineer burned 215 cords of wood. Another burned 42 cords, must have been a much smaller train. Anyway, so they installed this engine coal storage in 1907 and retired it in 1948. So here it is. Oh, that's obvious how that works, right? That's basically on the val maps. It's like, what is that? Well, turns out these are pits. You have two tracks and you have a pit, a common pit. Either one, if you dump, goes into this middle here. Then you have a ring of rail, track going around there, and a little crane that can drive around there. And it's always the same distance from the middle of the pit. So it has a fixed boom, which is 60 feet, I think. Yeah, 60 feet. And so it can pick up here with a clamshell bucket, swing around, and make these piles. Now, it doesn't make them more than 25 feet high. And it can drive around to the other side of the tracks and make a pile over here, too. So that's what it looks like from the side view or whatever. And now this isn't the O&W. This is a bigger operation with weird, two tracks involved. But it just shows the layout of the pits and the little crane that can with a clamshell bucket. O&W had a much smaller thing with just a single two-rail track, a smaller crane. Here are the big anthracite piles, but behind it with these little bituminous piles. So funny little crane. Again, fixed. They couldn't boom up or boom down. You didn't need to. It was just, yeah, these guy wires held it at a standard length, 60 feet to the middle of the pit. And obviously it could rotate. Yeah, these rollers and all that. Funny little house. And so here's even the drive. So they had a shaft coming out, running a little thing on the outside of the wheel to just drive it around that circle. So this was taken after they shut things down, the coal system down, 1946. Anyway, so we saw this picture before. It shows the 3 reloading towers. Well, 2, there's one over here. But in the background, you can just barely see. Here's the engine coal thing. We can zoom in. So there's a much lower pile that it makes. And here are cars that brought the coal in, basically. And when they needed that, I guess they would load up the hopper cars again and then take that out to the engine coaling station, or even take it to other locations. So is there anything left? Well, not much. So here's the 1916 configuration. The only thing left is this road department stores building. There are a couple of them, but this one's the only one that shows up in the next thing. And that's part of is a soy sauce manufacturing company. So here's what it looks like now. So here are the piles and the tracks and the engine coaling thing. And there's a big scrap yard and these various things. I think this might be the, well, here, it's Fairbanks, whatever they make. Anyway, so it's a big warehouse. Here's that one Wajashan maker. And there's that one building that's still there, at least in this photo. I think there's another one over here out of this picture. So, okay, so that's the end.